is types of spectrophotometer. There are two types of spectrophotometer from this dispersive infrared spectrophotometer and Fourier transform spectrophotometer. When we come to dispersive infrared spectrophotometer, this use a monochromator, for example, sodium chloride prism or grating, to separate light into its frequency or to change polychromatic wavelengths or frequency to a monochromatic wavelengths or frequency. An infrared spectrum generated by a dispersive instrument is normally a plot of wave number per centimeter or wavelengths millimeter versus percent transmittance. This is usually, but also absorbance versus wavelengths or wave number. As we can see from the instrumentation picture, there is infrared instrument and monochromator and reference holder and sample holder, and also amplifier and detector. Containing all movable parts which causes mechanical spillage, and these instruments have a slow scan speed, or the rate of scanning is low, and also having low resolution, less resolution, accuracy and sensitivity, because they may be the involvement of stray light, and this stray light may pass through which cannot pass to the sample and may reach to the detector. This affects the intensity of observed light. Stray light means a light that reaches to the detector which cannot pass through the sample, and it affects the the intensity of absorption of light, because it increases the transmittance of light and leads to the error of the scanning. The other is Fourier transform IR spectrophotometer. The IR radiation does not pass through the prism or the grating or the monochromator, but through the IR radiation pass through the interferometer and then collectively sent through the sample. An interference pattern generated by observation within the sample is called an interferogram. This is intensity versus time of a spectrum. FTR, or Fourier transform IR spectrometer, collects all wavelengths simultaneously and it scans at once. It works based on interferometer, which having a beam splitter, a fixed mirror and a movable mirror. When the beams are combined an interference pattern is created. This means that when light is split into two parts by the beam splitter, and one part of the beam is moved to the fixed mirror and one part of the beam is moved to the movable mirror, and the light or the beam is reflected back to the beam splitter from the moving mirror and fixed mirror back to the splitter, and combined an interference pattern is created. The combined beam reaches to the detector by passing through the sample. After that, obtaining spectrum is referred to as interferogram. That means intensity versus time. This will be amplified and translated into IR spectrum by Fourier transform IR spectrum. This machine used to convert interferogram to or intensity versus time graph to absorbance or transmittance versus frequency or wavelengths diagram or spectrum. There are advantages over that of dispersive IR spectrophotometer. They have better speed. A complete spectrum can be obtained during a single scan of the moving mirror, while the detector observes all frequencies simultaneously. That have wide variety of frequencies pass through this mirror, and a complete spectrum can be obtained at a single scan of different wavelengths or frequencies. An interferometer is in an FTIR instrument does not separate energy into individual frequencies for measurement of the infrared spectrum. For a transform, IR's advantage is that many scans can be completed and combined on the FTR in shorter time than that of one scan on its dispersive instrument that have higher speed of scanning than that of dispersive IR spectrophotometer. The other advantage or benefit of Fourier transform spectrophotometry is better sensitivity and resolution. This is because the FTIR instrument does not cause slits to limit the individual frequency. There is no slit, but in dispersive IR spectrophotometer there is slits that are used for selection of specific wavelengths that the analyte absorbs maximum absorption, reaching the sample and detector as a dispersive instrument does. So the Fourier transform instrument does not use exotic slit to limit the individual frequency. There are also fewer mirror surfaces in FTIR spectrophotometer. Therefore, there are less reflection loss than in dispersive spectrometer. That means the energy that's carried by the radiation already reached to the sample without the loss of its energy by reflection. As a result, more energy reaches to the sample and hence the detector in an FTIR spectrometer than a dispersive spectrometer. Higher sensitivity and clear spectrum that have higher sensitivity and clear spectrum. The other advantage is simpler mechanical design. There is only one moving part, the moving mirror, resulting a better reliability, and also elimination of stray light and emission contribution. As we know, stray lights affect the reliability or the accuracy of the measurement because stray light is a light that cannot pass through the sample, but it reaches the detector, and it results decreasing the intensity of absorbed light. The interferometer in the FTIR modulates all the frequencies. The unmodulated stray light and sample emission, if any, are not detected. As a result, the elimination of stray lights and creates reliability or accuracy of measurement. The other possible or great advantage of FTIR is powerful data station. Modern FTIR spectrometers are usually equipped with a powerful computerized data system. It can perform a wide variety of data processing tasks and such as a Fourier transformation, baseline collection, and library searching. This is more important for the identification of compounds with the comparison of standard IR spectrophotometer with that of the compound of interest. The other topic is sample compartment and sample preparation. That means which sample holder or compartment are available or suitable for analyzing IR radiation, because different sample holders that may be absorb IR radiation. As because of this, the sample compartment or the sample holder cannot absorb IR radiation, and which samples are available for the identification and the absorption of IR radiation. When we come to sample cells must be constructed of ionic substances. From this, sodium chloride and potassium bromide cells may be used. Moisture from air and sample should be avoided because moisture can solubilize the sample holder and affects the integrity of the sample holder, because sodium chloride and potassium bromide are soluble in water. Even with care, their surface eventually becomes fogged due to absorption of moisture, and this the formation of fog affects the transparency of the sample holder. and the sample holder become very thin path length up to 0.1 to 1 millimeter, and the sample concentration about 0.1 up to 10% of the total solution. This is different types of sample holders. For example, sodium chloride from 40,000 up to 600. This has the wide coverage of frequencies and soluble in water, slightly soluble in alcohol, and low cost, fair resistance to mechanical and thermal shock, easily polished. The other is potassium bromide, calcium fluoride, barium fluoride, potassium chloride, and cesium bromide, the salt of halogen. The other is sampling technique. It is possible to analyze sample with IR spectrophotometer that have different physical status. For example, liquids, solids, and gaseous forms of the sample are detected by IR spectrophotometer. The material used to contain the sample must always be transparent to the IR radiation, and the sample holders that does not absorb IR radiation, because there is no interference between the analyte and the sample holder. As a result, the sample holder that does not absorb IR radiation. From the sample, solid samples can be identified or detected by different forms. For example, solid dissolved in a solvent. The sample is dissolved in the suitable solvent, that is carbon tetrachloride, and sample solution is taken into the cell is made up of sodium chloride or potassium chloride. The solvent carbon tetrachloride is selected because it is non-polar and it does not solubilize the sample holder, and that does not affect the transparency of the sample holder. The other is solid film. The sample is dissolved in the solution. It is evaporated on the surface of the sodium chloride or potassium cells. These films are detected by the IR radiation. The other technique of sample techniques are mole technique. That means the sample is mixed with equal amount of mineral oil to form a thick pastes. As the sample is detected as a paste and in the form of paste, and it is spread on the IR sample cell made up of sodium chloride and potassium bromide. The other one is pressed tablet technique. The sample mixed with 100 times that weight of the sample holder powder, and is pressed under high pressure to form a small pellets. The pellet technique is more advantageous than other methods. Pellets can stored for a long period of time because it is solid dosage forms that have higher stability to the environment. The disadvantage of pellet form or pellet technique is using higher pressure for the formation of pellets leads to changes in the polyformic state of the crystals. Crystals may be changed from metastable to stable or amorphous form. This affects the integrity of the sample. Solvent for dissolution of solid samples should be free of water to avoid damaging of sodium chloride cell surface, because sodium chloride is soluble in water, and when the solvent becomes water soluble or that have water content, they affect or damage sodium chloride or potassium bromide sample holder. and a reference spectrum of the blank solvent should be obtained and subtracted from the sample spectrum because the sample or the solvent may be little absorption of IR radiation. This affects the accuracy of or the reliability of the detection, and as a result, to correct this, you must be perform a blank absorption in the radiation that must be subtracted from the sample. The other form of the sample is liquid sample. A drop of liquid organic compound is placed between a pair of polished salt plates, that of sodium chloride or potassium bromide, because the liquid samples become non-polar or hydrophobic because the sample holder is sodium chloride or potassium bromide that are soluble in water. When hydrophilic or water soluble placed in the sample holders that have water soluble, they become damaged and unable to detect or hold the sample correctly. When the plates are squeezed gently, a thin liquid film falls between them. Salt plates break easily and which are water soluble, as we said before. Organic compounds analyzed by techniques must be free from water, as we said above. The pair of plates is inserted into a holder that fits into the spectrometer. A compensating cells containing pure solvent is placed in the reference beam of the instrument to correct the absorbance of the sample correctly, because some solvents made little absorption in that radiation. The solubility of the sample its own minimal absorption in IR radiation. The select solvent have free from IR absorption and or minimum absorption in the IR region, and also the solvent should not solubilize the sample holder and suitable for the solubility of the sample that you are interested. The solvent, the most commonly used solvents are carbon tetrachloride, chloroform, and carbon disulfide. This is a non-polar solvent because the sample holder is that does not affect the integrity of the sample holder. The other sample or the other form of sample is gas samples. The gas samples are measured in the special sample cells because gas, as we know, gas is IR spectrum is obtained directly by permitting the sample to expand into evacuated special cells. A gas sample cell consists of a cylinder of glass or sometimes metal. The cell is closed at both ends when an appropriate window materials that of sodium chloride and or potassium bromide and equipped with valves or stopcocks for introduction of the sample. Because gas samples are volatile and difficult to handle, it is more evacuated technique are used to eliminate the effect of or the sample difficulty. There are different pharmaceutical preparations that are detected by for example, when we use potassium bromide as a sample holder, azolamide tablets, cimetidine, HCl, hydrochloride, warfarin, prednisolone, chlorpromazine, spironolactone are detected by using potassium bromide as a sample holder, and others are detected by this method of analysis.